double summation first summation over j equal to 1 to 2, second summation over I equal to 1 to 8, xi comma j equal to I equal to 1 to 8, xi comma 1 plus summation over I equal to 1 to 8, xi comma 2. MO mode, value that occurs most frequently in population. MR, sorry, this one MO mode, value that occurs most frequently in population. MR mid range, MR equal to x max plus x minimum divided by 2, whole divided by 2. MD sample median, half the population is below this value, half the population is below this value. Q1 lower first quartile, 25% of populations are below this value. Q2 median per second, 50% of population are below this value. Here this is lower divided by first quartile. Sorry, for Q2 median second quartile, 50% of population are below this value equal to median of samples. Q3 upper third quartile, 70% of population are below this value. X bar sample mean, average arithmetic mean, x bar equal to 2 plus 5 plus 9 divided by 3 equal to 5.333. A square sample variance, population samples variance estimated, a square equal to 4. A square equal to sample variance, population samples variance estimated, a square equal to 4. S equal to sample standard deviation, population samples standard deviation estimated, S equal to 2. Z suffix x standard score, Z suffix x equal to x minus x bar divided by x suffix x. X approximation, distribution of x, distribution of random variable x, x approximation n of 0,3. N of mu comma sigma square normal distribution, Gaussian distribution, x approximation n of 0,3. V of a comma b uniform distribution, equal probability in a range a comma b, x approximation e of 0,3. Exponential of lambda, exponential distribution, f of x equal to lambda e power minus lambda x. Condition x is greater than or equal to 0. Gamma of c comma lambda, gamma distribution, f of x equal to lambda cx power c minus 1 e power minus lambda x. Tau of c divided by tau of c, x is greater than or equal to 0. A square of k, chi square distribution, sorry, this is not x, chi square of k, f of x equal to x power k by k divided by 2 minus 1 e power minus x by 2 divided into 2 power k by 2 tau of k by 2. F k1 comma k2, f of k1 comma k2. F distribution, here I have to say open bracket close bracket. F of x, that is chi square of k, chi square distribution, f of x equal to x power k divided by 2 minus 1 e power minus x by 2 divided by open bracket 2 power k by 2 tau of k by 2 close bracket. Bin of n comma b. Binomial distribution f of k equal to n c suffix k p power k 1 minus p whole power n minus k. Position distribution, position of lambda. f of k equal to lambda power k e power minus k divided by k factorial. Geo of p, geometric distribution, f of k equal to p of 1 minus p power k hg n comma k comma hg of n comma k comma n small n. Here caption Hilbert geometric distribution. BERN Bernoulli distribution. Bern of B. Bern of P. Combination symbols. N factorial. N factorial equal to 1 dot 2 dot 3 dot up to n. 5 factorial. For example, 5 factorial. 1 dot 2 dot 3 dot 4 dot 5 dot. That is 1 into 2 into 3 into 4 into 5 into not 5 up to 5 only. So 120. N P base k suffix k permutation. N P suffix k equal to n factorial divided by n minus k whole factorial. So 5p3 5 p suffix 3 equal to 5 factorial. Is 5 factorial divided by 5 minus 3 factorial. So answer is 60. Here n c suffix k or nk combination n c base k equal to nk equal to n factorial divided by k factorial into n minus k whole factorial. 5c3 suffix 5c suffix 3 equal to 5 factorial into that is whole open bracket square bracket 3 factorial and open bracket 5 minus 3 factorial close square bracket equal to 10. It means into 5 factorial divided by 3 factorial into minus into 5 minus 3 factorial equal to 10. Set theory symbols. This is called set. You know already. A collection of elements. A equal to 3 set of 3, 7, 9, 14. B equal to set of 9, 14, 28. A intersection B intersection. Objects that belong to set A and set B. A intersection B. Here 9 both 14 both. A intersection. A union B. Objects that belong to set A or set B. 3, 7, 9, 14, 28. These three here. Okay. Subset A, subset B. Subset has fewer elements or equals to the set. Example, set of 9, 14, 28. Subset of 9, 14, 28. Proper subset, strict subset. A subset B. Proper subset. Subset has fewer elements than set. 9, 14. This is the subset. This is the set. So 9 14 subset 9 14 28. This is the subset, this is the set. Okay, A, that is non subset, A not subset to B. Left set not a subset of right set. Left set not a subset of right set. This is left set, this is the right set. So left set is not a subset of a right set. So that's why this symbol, not subset. Left set is left set not a subset of right subset, right set. Left set is not a subset of right set. Superset, A superset B, it means set A has more elements are equal to the set B. Set A has more elements are equal to the set B. 9 14 28, 9 14 28, it means equal. This is the set A, this is the set B. So here which one is suitable? Set A has equal to the set B. If we have more elements having, that one also here applicable. Set A has more elements than to the set B. Proper superset, strict superset. Proper A, proper superset B. Set A has more elements than set B. A has the set A, this one set A, this one set B. So set A has more elements than set B. Here it means strict superset. Okay, not superset. A not superset B. Set A is not a superset of set B. Set A, this one set A, this one set B. Set A is not a superset of B. This is superset of set B. This is the B set B. This is the set A. This it means here this set A is not a superset of set B. 2 power A power set, 2 power caps A, all subset of A. P of A power set, all subset of A. A equal to B, equality. Both sets have the same members. Both sets have the same members. A having 3, 9, 14, B set having 3, 9, 14. So A equal to B. So equality. Both sets have the same members. A power C complement. All the objects that do not belong to set A. Which object is not having, it is not belong to set A. All the objects that do not belong to set A. Relative complement. A relative complement B. Objects that belong to A and not to B. A equal to 3, 9, 14. B equal to set of 1, 2, 3. This is also A equal to set of 3, 9, 14. Here A minus B equal set of 9, 14. So 3. So objects belong to A, objects that belong to A and not B, not B. A minus B relative. Object has belong to A. Objects relative